A study by the U.S. Department of Energy found that converting retiring coal plants to small modular nuclear reactors could significantly save capital costs. Terra Praxis is one of the organizations working on this exact case, and for more, I'd like to bring in Terra Praxis co-founder Eric Ingersoll. Eric, thank you so much for joining us. Why coal plants in this case, and are there opportunities for other plants as well?
Well, coal plants produce 35% of carbon emissions on the planet, and a large number of grids still rely on coal plants as reliable generators and as the backbone of electricity generation. And in some countries, the dependence on coal is as high as 90% of electricity generated. And one of the challenges with getting rid of coal plants is that we really need to replace them with a generation resource which is similar in its performance. A generator which can turn on and off when you want it to, a generator which can supply, reliable energy for long periods of time, including in cold, dark nights. And the other challenge that we have, which is not a technical challenge, but is a political and an economic challenge, is that communities have grown up around these coal plants. And, when you shut down a coal plant in a community, that community may be entirely or largely dependent on the jobs and revenue from that coal plant. And this means that it's not a politically simple thing to shut down a coal plant. In fact, what we've seen in the US is massive resistance, political resistance, which is undermining the ability to take action on climate.
You mentioned needing these buy-ins from these coal communities. Advanced nuclear is growing in popularity and support, but there are still obstacles there. Can you share a little bit about those obstacles with us?
Sure. Well, many of the advanced nuclear technologies and companies are technologies that have been in development and even in the prototyping stage for decades. But what we have to do now is transform them into commercially viable products. And that means commercial demonstrations, which can be expensive and require a lot of what's called non-recurring engineering, a lot of engineering expense, and also licensing. So these technologies have not been used commercially, and the regulators don't have the same understanding or comfort with these technologies that they do with light water reactors. So the path of getting through the regulator is a little less certain, and because that's expensive and the time that it takes, the longer it takes, the more expensive it is, there's quite a lot of financial risk for the companies bringing these products to market about how long the licensing process is going to take and how much it's going to cost. I think the other area where we're seeing some, where you would normally think that there would be challenges is around community acceptance. And what we've seen in the US and in a few other countries that are looking at a coal to nuclear transition as part of a climate strategy is that when people are asked in the abstract about nuclear energy, they answer the question in kind of an abstract way. When they're asked whether they would like to have a new power plant in their community when the old one shuts down, most people say yes. And what it causes them to do is actually look practically at what the risks are from having a nuclear plant in their community. And those of us in the field know that the risks are extremely low and that these plants are incredibly safe. But unless you have a motivation to learn that, you may just sort of, listen to the opinions that you get from anti-nuclear organizations or from, uninformed people on social media. So one of the interesting trends of what used to be an obstacle but is now sort of going away is this transformation of public opinion that we're seeing. And this is also, in the US, we see this in that there are supporters for advanced nuclear on both sides of the aisle. And in Europe, we're seeing parties coming to power in Italy, Sweden, the Netherlands, which have strongly included nuclear energy in their platform, their energy strategy. So I think we think that we're on the kind of verge of a real transition, maybe not a nuclear renaissance yet, but a real change from the idea that we really don't need nuclear to accomplish the energy transition to recognizing that it would be extremely useful and helpful if we had that at scale.
You mentioned the Terra Praxis Repower platform. You're trying to help customers through the process. Tell me a little bit about the platform because you're trying to change the nuclear delivery model, right?
Yes, exactly. So to be helpful in solving the climate challenge, nuclear energy, we're going to have to deploy a very large amount of nuclear energy very quickly. And although there have been periods in the past in certain countries, such as France and Sweden, where a lot of nuclear power was built very, very fast, it was kind of under conditions that we don't have today. This very strong centralized government, government-owned utilities, incredible sort of consensus, techno-economic consensus, if you will, around what should be done. And those countries accomplished incredible things. The decarbonization that occurred during those rapid build-outs in Sweden and France is still the fastest decarbonization that has ever been achieved so far to date. So it's very promising, but I think with the new design that we have for markets, and the sort of idea that the delivery of power plants should also be done on a sort of competitive market basis, I think we're going to need a different delivery model for nuclear that looks more like the kind of projects that project developers develop with solar and wind, where a project development company can get an offtake agreement, identify a site, and go through the financing and development of that project and really expect that project to be delivered for the cost that was agreed and in the time frame that was agreed. It is possible to deliver projects, nuclear projects, on time and on budget, but it takes a very special set of circumstances to do that today. And we need this to be much more broadly deployable than those circumstances would permit. So what Terra Praxis is leading is a consortium focused on how we can apply best practices from outside the nuclear industry. For example, there's a lot we can learn from the data center industry. 10 or 15 years ago, data centers were built for $20 a watt. They were always late, and they didn't always work very well when they were delivered. Now, they're delivered on time and for $3 a watt. And when you look at the kind of problems that the industry had to solve to make that transition, those are exactly the kind of problems that we have today in the nuclear industry with nuclear delivery. So our consortium is really about how do we take those innovations that are available in other places and work with the suppliers of nuclear technology, the developers, and the customers or off-takers for the power, and kind of create a new consensus and a new model for how these projects can be done at scale.
You segued that very nicely talking about the consortium because you all have a lot of partners, notably Microsoft. So how will Terra Praxis leverage the use of AI through this platform?
Well, that's a great question. So AI is both driving the demand for the solution and can help us make that solution easier to deliver. So we have, Terra Praxis has a partnership with Microsoft, and one of the areas that we're working together on is the use of generative AI for licensing. So the documents that you have to file with the nuclear regulator to get permission to build the product are very long and complicated and require the management of a lot of detail and have to be correct. And usually the way this is done is by hiring lots of expensive people to write huge, long documents, and then hire even more expensive people to read them over and make sure they're correct. And this leads to multi-year licensing timelines and hundreds of millions of dollars to license a project. But we know that that kind of document, a highly structured document with a lot of technical information in it, that those can be understood by a large language model, and you can generate a document like that and give the AI the specifics of the site that you're looking at and say, please use these specifics instead of the ones that are in your generic document. And we've actually been able to demonstrate, at our last consortium meeting, we had a live demonstration of writing a draft environmental impact statement for a nuclear plant from the work that has been done so far. And obviously you'll still need to check these things. It's not there'll still be humans in the loop, but but we could see a dramatic acceleration of the process, and we think this is going to be necessary to, if we're going to repower the U.S. coal fleet, as you alluded to earlier. That's several hundred projects that need to be licensed. The other piece that's very interesting is that we believe there's as big an opportunity to use AI for the reading these applications as preparing them. And so we're interested in starting a project with nuclear regulators to use AI as a way of sort of checking and verifying and maybe even creating a more interactive process for the development of these license applications. So you would submit a draft, their AI would check it and identify areas where improvement was needed, send it back, you do some more work. And this is sort of, because sometimes what happens with these types of things is a lot of work gets done and then you give it to the regulator and they're unhappy with some part of it. This would allow you to kind of get past that and end up with something that both sides were happy with when it was finished. We think the possibility to accelerate the licensing process by more than 90% is there. Another area that we're looking at that can leverage AI in this is automated design. So there's a huge amount of detail that needs to be designed for a successful project. And we know from the work we've done looking at what makes nuclear projects successful and unsuccessful, that doing as much design as possible up front is a key success factor. But designing Vogtle, for example, in the US was probably $1 billion worth of work. And that's why people don't want to do it before construction starts. So finding ways to automate parts of this design through rules and kind of smart design systems that have the regulatory compliance built into those rules, so that the thing cannot design something that's not compliant with the regulation. You still have to check all this stuff. There'd still be humans in the loop, but the rate at which you could get to a thing that you could start checking would be dramatically accelerated.
Eric, thank you for these insights. And for more insights, please join us on the Enlit community.